Hi, this is Mike 0 Sierra November Zulu, and I'm just going to give you a quick demo of the latest Pycom Radio Controller walkthrough. You can see here I've got a application and I can just double click on it, start it up. I'm running version 2026-06-16 today. The latest version. There's a couple of minor fixes that I put in from putting together a PSK Reporter application. Anyway, let's get started. So you can see here that we've got a connection dialog here. You can use the settings, manage radios, to set up your radios and save them so that they persist between restarts. But as a quick start, we can just use the dialog here, and I can click connect, and it should connect us to the radio. You can see that we've got full twin transceivers for the Icom 9700 here. Pycom's undergone a redesign of the main display here, bringing in new features such as the attenuator in advance of perhaps adding some other radios later. We've got the ability to copy main and sub, as you'd expect, copying the main, switching the main and sub transceivers. We can copy the VFO A and B and switch between them, as you would expect with these buttons down here. As per earlier versions of Pycom, we have the ability to load and save memories. I'm just going to quickly move over to the FT8 on 2 meters. So if I zoom on in here, you can see here that we're on the FT8 region of the 2 meter band, and that we've got a full band plan, multi-region band plan that's configurable from the settings. Again, if we go to configuration, you'll see that we have the ability to select the various regions, region 1, 2 or 3, and that will update the band plan as per your area. I'm just going to use WSJT-X to send out a little FT8 so that we can look at some of the other features. So if I bring that over onto the screen here, you can see that WSJT-X is trying to connect to the radio at the moment, I believe, on startup. Yeah, it's doing that. We're using FT8. The rig control server is in push to talk and read only mode. This means that Pycom will respond to rig control commands and allow push to talk to be set, and you receive and transmit, but won't allow WSJT-X or anything else to send any write commands such as changing frequencies. This is really useful when you're controlling satellites with another external program. You can enable the push to talk and read only or full control by selecting this option in the settings menu. I'm just going to leave it on push to talk and read only for now. So if I go back to the scope and check out what we're doing here, we've got loopback speakers and external microphones set up so that I can actually talk and send my voice to the radio. I'm going to quickly change that to the loopback microphone and do a quick FT8 transmission. Just bear with me. I can see that we're not getting anything through here, so something's not quite right at the moment. I think I've got squelch turned on. There we go. There. Yeah, so if I turn the squelch off, you should hear the radio coming through. I'm just going to quickly chuck it over onto the loopback microphone, so you won't hear me speaking for the moment, but I'll just send a couple of FT8 signals. There we go. Maybe you can hear me. So if I cancel this, we've sent the FT8. We don't need to use WSJT-X anymore. But you'll be able to see one of the new features that I've built into the application, which is the PSK Reporter. So you'll see that when I bring up the PSK Reporter tool, it automatically has my call sign copied over from the settings. I'm going to look at just FT8 since we've just sent some FT8 just a moment ago, and I'm going to query, and hopefully someone has sent us reception report. You can see that I've got a few reception reports here. I can click on the View Map button and I get a nice map with the report, reception reports plotted on the map. If I click on the, you wouldn't have seen that, but if I click on that, it opens up the individual in the QRZ page on my other screen. Anyway, this will automatically refresh every 5 minutes, so you can have this map window up, doing your FT8 or other transmissions, and it will automatically refresh. We should see that with I should see a few more signal reports coming up as I look at the other things in the program. As I said, that will automatically refresh in a couple of minutes' time. So let's just squelch the radio. So another nice feature within Pycom is the ability to use an S.A.T controller. So if we look at the S.A.T tab, which is enabled from the settings menu up here, you can enable the S.A.T controller here, and you can see that I'm going to be polling the S.A.T every half a second. I can open the dashboard. So if I open the dashboard, you can see we should have a satellite coming over in a few minutes time. In about 1 minute 37, we've got the RS-44 satellite coming. It's a rather low pass, but I might be able to get a contact on that pass. We'll see. I had one earlier today. You can select the various transponders here. I'm going to leave it on the voice section of the linear satellite. So now that I've selected the satellite within the S.A.T control, I can close that window, and I can come back over to Pycom and click the Start Tracking button. Now you'll automatically see that the screen's starting to update. The radio's been automatically set to the voice settings for that transponder. You can see we've got an acquisition of signal coming in about 40 seconds, and the various satellite statistics are printed on the screen here. I can actually log all this detail into the Pycom logs by clicking on the Log Pass detail button there, and then all of the individual queries from S.A.T and the position of the satellite, each iteration will be printed in the log file, and you can view that through the log file here. But moving on over to the waterfall, you can see here we can zoom on into and zoom out. Let's probably leave it about here. I'm going to click on the Fix button. This Fix button is useful when using satellites. You can see the Doppler has been applied here, and this just means that our signal is going to be centered on the waterfall rather than drifting as it would as you control the Doppler. This doesn't look like it's refreshed. I don't know why. Let's see what has happened here. It's probably a bug. There's a whole lot more signal reports that have come in over the last few minutes. Maybe I needed to leave that window open, but I'll look into that later. Anyway, going back to the satellite. So we need to change the reference level just so we can see a little bit more detail on the scope, and let's check to see that we've got our preamp on, which it is. So we're all set. I know that we probably want our RIT to be negative 1.6. I'm going to use the RC38 controller. I can press the button to highlight the RIT, and I'm just going to use the dial here to change the RIT down to about there. That should be about right. You can see the satellites already got some signals coming over, and we're in business. So let's turn off the squelch and see if we can't make a contact. So let's make sure we have the
CQ satellite Golf 1
external
Alpha Kilo. Golf 1 Alpha Kilo calling CQ.
So that was Golf 1 Alpha Kilo.
CQ satellite Golf 1 Alpha Kilo. Golf 1 Alpha Kilo calling CQ.
Golf 1 Alpha Kilo, this is Mike 0 Sierra November Zulu. Mike 0 Sierra November Zulu.
Yeah, Mike 0 Sierra November Zulu. You're 59, Italy Oscar 83 Papa India, go ahead.
Excellent, you're nice and clear as well. 59 India Oscar 91. Thanks very much for the QSO.
Roger, Roger, thank you. There's a little bit something wrong with your audio, it's not quite right. Just have a quick listen to it. 7-3.
Nice one, thanks for the QSO, 7-3s. Well, he gave me an audio report, that's nice to know. But I can log that contact here, right within the application. And save that QSO, and then I can upload that to my cloud log instance, which will be there we go. Let's just mute that for a minute, and if I bring up my cloud log instance, let's see what's going on here. We should see that there we go. I've logged that contact, and that will automatically propagate through the various QRZ, logbook of the world, etc. And you can see here that we've contacted this guy here, Philip Webster, which was quite nice. I might get in contact with him to see what that audio actually sounded like. But there we go. There's Pycom Radio Controller. Actually, there's one more thing I'd like to show you. So another new feature is the Amsat status page update. So if I come along here and click refresh, you can see here that we've automatically set up on the RS-44 satellite because it's being tracked in the S.A.T controller. I click on confirm and submit report, and that report's automatically being submitted to the Amsat status page, so other people know that the satellite's been heard. And actually there is a couple of other things I'd like to show you perhaps. So I've got this new automatic signal detection. You can see that the signals are being detected here on the scope automatically. If I zoom out, maybe we'll see a few more. So you can see it's quite busy. If I click on the capture here, you can see that it's automatically detected these two signals. I'm just going to delete them because I don't want to give the classifier, which is a machine learning classifier, wrong information. So I'm just going to highlight and select these signals here, which I'm going to save for training data. So I can train the signal classifier on real over-the-air signals. So you can see here that the machine learning model knew the first one was SSB. It was 91% sure, which is wrong, that the second signal was a FM signal, and the last one there is again SSB. I'm going to correct it and save that as an SSB signal, and save that capture for training the model in the future, so it can get a bit smarter and automatically understand what signals we're looking at on the waterfall. I can click the camera here again and get some more captures here. You can see it's automatically picked up these signals. As I said, they're probably not wide enough. The automatic signal detection is quite narrow there, so I probably want to train it on data that's a little bit more accurate than the automatic signal detector bandwidth there. But the model was a scope CNN, or a convolutional neural network, which looks at the image on the waterfall and tries to identify the signal via patches or little areas and pieces together, lots of different parts of that waterfall to try and identify the different signal types. And then as well as the image, it's also got some other data such as the frequency, the span, the scope span, the reference level, and the mode. And these additional data augmentations, along with the scope, give the classifier all the information it needs to be able to train and predict, train and what's the word I'm looking for? Not predict. Report that it thinks that this particular signal is of type SSB, for example. Anyway, that's it for me for this video. I hope you enjoyed it. Thanks, and 7 threes.